Strings. In this video, we will continue exploring the Java string class. At the beginning of this unit, we introduced 5 variable types: int, double, boolean, char, and string. However, what was not mentioned was that in Java, there are 2 types of values. The first one being the primitive value. What is a primitive value? A primitive value is a single piece of data. For example, an int is just a number. A double is just a number. A boolean, either true or false. A char is just a single character. In Java, one way to know that you're dealing with a primitive value is if the variable type begins with a lowercase letter. String, on the other hand, is an object. An object is a collection of data joined together to form one entity. So while primitives are a single piece of data, an object is a collection of data. A string isn't just a single character, it's a collection of characters. Primitive values are the building blocks of objects. They are what objects are made up of. And the way you know you're dealing with an object in Java is if the object type begins with an uppercase letter. The majority of variable types that you're going to use in Java are going to be object types. Now, let's explore the difference in how primitives and objects are created in our Java code editor. When primitives are initialized, they'll be initialized with just a single value, as you see here with the 2 ints. Because again, primitives are just a single piece of data. Objects, however, are initialized using the new keyword, a new operator, to indicate that we're creating a new object. Now, string is an exception in the sense that it's one of the few objects that can be initialized 2 different ways. As you can see here, we could also initialize string by just typing the characters within quotation marks. However, in this video, we're going to focus on using the new keyword, since that is the type of string you're going to encounter more often during your programming career, and it is how the vast majority of objects are created. So, let's explore what happens when we compare these objects using the double equals operator. In the case of comparing the 2 ints, x1 and x2, when we output the result, we get true. And that is because x1 and x2 contain the same exact content. They both contain the value 5. And when you compare primitives using the double equals operator, that's all the operator will check for, to see that the variables, the 2 primitive variables, have the same exact content. However, when we compare s1 and s2 using the double equals operator, we get false, even though both s1 and s2 contain the string hello. The reason for this is because although s1 and s2 both contain the same string, they're not the same container. They are 2 separate containers, just like having 2 bottles of Sprite. Yes, both bottles have the same beverage inside of it, but they are not the same bottle. They are 2 separate bottles. In summary, the double equals operator, when used on primitive types, simply tests to see if the variables have the same value. When used on object types, however, the double equals operator tests to see if the variables refer to the same exact object. S1 and S2 do not refer to the same exact object. Now, how do I know that? I know that because we used the new operator when we initialized both of them. Anytime you use the new operator to initialize an object, you're telling that variable to refer to a new separate object. Contrast to this line of code. Suppose I declare a string s3, and instead of using the new keyword, I simply initialize it to s1. In this case, I'm not creating a new object for s3 to refer to. Instead, I'm telling s3 to refer to the object that s1 refers to. So in this instance, s3 and s1 are referring to the same object. Thus, if I were to compare s1 and s3 using the double equals operator, I'm going to get true, because even though they're objects, they refer to the same exact object. Now, that all being said, this is not the most common goal for comparing. Most of the time, we're not going to be interested in knowing if 2 variables refer to the same exact object. Most of the time, we're only interested in knowing if the 2 variables have the same exact contents. So, if that's our goal, how do we test that with objects? We do that using the .equals method. Here, we're comparing s1 and s2 using the .equals method. When we compared them using the double equals operator, we got false because S1 and S2 don't refer to the same object. But the equals method doesn't care about that. The equals method simply wants to know, do S1 and S2 have the same content? Do they contain the same values? Which they do, hence why true gets printed out. In summary, the dot equals method returns true if the objects referred to by the two variables have the same exact contents, and false otherwise. Now suppose I compare S1 and S3 using the dot equals method. We already know that S1 and S3 refer to the same exact object, so it goes without saying that the objects they refer to will have the same exact content. Thus, true will get printed out. Now, suppose I have two strings. And by the way, the dot that you're seeing isn't actual Java code. I'm just putting that there for now because the actual values of the string isn't important to the point that I'm about to make. Now, suppose I have two strings and I want to compare them, but not just for equality. I want to know which string comes first alphabetically. In that case, I'm going to use the compare to method. The compare to method returns an integer based on how the comparing object compares to the parameter. In this example, S1 is the comparing object and S2 is the parameter. If S1 comes before S2 alphabetically, then the method will return a negative number. If S1 comes after S2 alphabetically, then the compare to method will return a positive number. And if S1 and S2 contain the same exact string, then the method will return 0. Now, notice that I simply said a negative or positive value will get returned. I didn't say what exact value will get returned. That's because, at least for this course, the exact value doesn't matter. All we care about is the value negative, is it positive, or is it 0? That information will let us know all we need to know about how the two strings compare with one another. Now, suppose I set S1 equal to apple and S2 equal to orange. And then I compare them using the compare to method. In this example, S1 is the comparing object, S2 is the parameter. Since apple comes before orange alphabetically, a negative number should get output. And that's what happens. Negative 14 gets output to the screen. Now, suppose I flip S2 and S1. Now I'm making S2 the comparing object and S1 the parameter. Since orange comes after apple, since the comparing object comes after the parameter, a positive value should get output. And that's what happens. A positive number gets printed. Once again, 14 isn't significant. All we care is that a positive value got returned. Now suppose I declare a third string and set it equal to apple, just like S1. When I compare S1 and S3 using the compare to method, 0 gets output because both S1 and S3 contain the same exact contents. Now, things can get a bit tricky when we start switching between upper and lowercase. Suppose I declare a string S2 and set it equal to orange once again, but instead of it starting with a lowercase o, it starts with an uppercase O. And then I once again compare S1 and S2 using the compare to method. Once again, alphabetically, S1 comes before S2. Apple comes before orange. So we should see a negative value get returned, right? Not exactly. A positive value gets returned for reasons that have nothing to do with the alphabet. In general, it's only completely safe to use the compare to method if you know that the two strings that are being compared either both contain only lowercase letters or both contain only uppercase letters. If the two strings have a mixture of upper and lowercase, then you can get unexpected results. If you're going to compare two strings that have a mixture of upper and lowercase letters, then it's much safer to use the compare to ignore case method. The compare to ignore case method works the same exact way that the compare to method works, except it ignores the casing. It won't get affected by the fact that there's a mixture of upper and lower case. Thus, in this case, when we print out the results of the method, we get a negative number as expected because apple, which is S1, comes before orange, which is in S2.